Now, in this question number 22, they are asking compare and contrast the bromination of benzene and bromination of phenol. So they are talking about two reactions. Include equation in your answer. Detailed mechanism is not required. They are not asking the mechanism. So they say the mechanism is not required. So we don't have to worry about the mechanism. So this part is there. And if you see a star mark in a question, that means we call them indicative point questions. Indicative point questions means these questions contain 6 points. So even though you write all 6 points, you don't get full marks. You will only get 4 marks for writing the 6 points. The other 2 marks, now out of 6 marks, you got 4 marks to writing all 6 points. The other 2 marks comes whether the answer shows a coherent logical structure, whether the answer is logically structured, and then only you get 2 marks. So here is not only the 6 point that we have write, we have to organize them in a proper way. Right. We'll see how we are going to write the answer for this one. Right. First thing what I'm going to write is it doesn't matter whether it's bromination of phenol or benzene, both undergo electrophilic substitution reaction. That's the first point I'm going to write. So first I'm going to write. So I don't need to rewrite it again. So that's one mistake students do. They will tell that bromination of benzene and bromination of phenol both are electrophilic substitution reaction. You don't need to mention that part though, because the reason is bromination of benzene and bromination of phenol, that's what we are talking about. It's mentioned in the question. So therefore they won't award marks for like writing these two again. So therefore first thing is we have to make sure that we will save our time. So first thing we are writing, simply we can write both reactions are. So when we see both reactions, they know what we are talking about. So first I'm writing both reactions are electrophilic substitution reaction. Electrophilic substitution. So both reactions are electrophilic substitution. So we write that one. Then what we have to do is we have to discuss about their products. So you can remember when you take bromination of benzene, this is how the bromination of benzene reaction will look like. So if I write bromination of benzene reaction, this is how the reaction will look like. For benzene, when you add bromine, Br2, you need a catalyst for this reaction. They are not asking the mechanism, so don't need to do the mechanism, but we'll write the reaction. Usually we add FeBr3 catalyst. So FeBr3 is our catalyst. Right. FeBr3 catalyst is there. So then what will happen? In the benzene ring, one of the hydrogen atom will get replaced by one of the bromine atom. Or one of the hydrogen atom there, it will come out and going with the other bromine forming HBr. So this is what will happen in bromination of benzene. So we can say that one thing we can see here is bromination of benzene requires a catalyst. A catalyst such as FeBr3. We need a catalyst like FeBr3. So we wrote the equation. But if you take bromination of phenol, we know that you don't need a catalyst and it won't be a monosubstitute. But here you can get monosubstitute product. Monosubstitution means only one bromine atom will get attached to the benzene ring. Most of the time, this reaction result monosubstitution. Monosubstitution means only substitution. only one bromine atom will get attached to the benzene ring. So that's what you call monosubstitution. But if you go for phenol, bromination of phenol, bromination of phenol, first thing is they don't require catalyst. Does not requires a catalyst. So one thing, they don't need a catalyst. We have to tell why it doesn't need a catalyst. And also they will undergo polysubstitution. Phenol is more reactive. Phenol is more reactive than benzene. More reactive than benzene. Therefore, polysubstitution will take place. Polysubstitution means more groups will attach to the benzene ring. Will take place. Polysubstitution will look like this. So when you have phenol, so phenol means a benzene ring has an OH group. For this one, when you add bromine, so 3Br2 will come. You don't need any catalyst. So what will happen in this benzene ring? 3 locations will get attached to bromine. This place there will be a bromine, and this place there will be a bromine. This position there will be a bromine, and those 3 hydrogen will go with other bromine atom forming 3HBr. Right, now you have to tell why this polysubstitution can take place, why this phenol does not require catalyst. The reason is, I can write in phenol, I'll use a different color, then you won't get mixed up. So if I draw it as a structure, this is the one. And we know that in phenol, there's a oxygen atom. In that oxygen atom, we have lone pair of electron. So what will happen? There's a probability this lone pair of electron get delocalized with the electron cloud of the benzene ring. So when the lone pair get delocalized with the electron cloud of the benzene ring, electron density on the benzene ring increases. That's why electrophiles are more likely to attack this benzene ring. So that's what we are writing here. We can write in phenol. So we write in phenol, the lone pair of electrons in the oxygen atom get delocalized with the pi electron cloud. Pi electron cloud means this electron circle. That means a cloud of circle. It's a ring shape with the pi electron cloud in the ring, in the benzene ring by increasing its electron density, by increasing its electron density therefore its reactivity increases. Therefore its reactivity, I'll put arrow upward, right? You can write the word increases. Now let's see whether we got our marks, right? So first we wrote that both reactions are electrophilic substitution reaction. Then we read that bromination of benzene requires a catalyst such as FeBr3. So then I wrote the reaction, and I said that most of the time this reaction results monosubstitution. Then I said that bromination of phenol does not require a catalyst, and phenol is more reactive than benzene, therefore polysubstitution will take place. Then I wrote the equation. Then I say why this more reactivity happens. Because oxygen atom has a lone pair. In phenol, the lone pair of electrons in the oxygen atom get delocalized with the pi electron cloud in the benzene ring. So oxygen atom electron pair get mixed with the pi electron cloud in the benzene ring, increasing its electron density. Therefore, its reactivity increases. Let's see the marking points. Both reactions are electrophilic substitution. They give us 1 mark. So I think I wrote that point here. So we'll go back to so I got that 1 mark. Difference, okay, first I talk about the reaction. Yes, so we get the 2nd mark. Then this reaction, 3rd mark. Benzene requires catalyst, alright. Benzene requires a catalyst, that's a 4th mark. Then phenol reacts with bromine. Phenol reacts with room temperature, reacts with bromine water. So we say phenol react with bromine water, no catalyst is required. Phenol is more reactive because the lone pair of electrons on the oxygen atom, the lone pair of OH ions are delocalized into the benzene ring. So therefore, it's more susceptible for electrophilic attack. So therefore, we say that delocalized into the benzene ring, making phenol susceptible electrophilic attack. So electrophilic attack is in the bracket. So it's not say which I'll just I have to see that part clearly. Okay, so allow an indication that the lone pair of oxygen atom phenol becomes delocalized with the ring. Yes, okay, that's fine. So that's the point they are expecting here. Here phenol react with bromine water, allow phenol react with bromine without a catalyst. Yes, so we have all 6 points in our answer. So if you take the allow answers and also, so they have allowed. So this point is fine, catalyst is there, does not require a catalyst. Okay, that's a point. 1, 2, 3, 4, and it's react with oxygen. So this is a sample answer where you have all the 6 mark. So from that we will get all the 6 points. Then we'll go for the marking scheme and see what are the points that they have asked us to write exactly. Right, so we have 6 marks. So what we were discussing here is they said compare and contrast bromination of benzene and bromination of phenol. That's the answer we wrote. So I just remove this answer. We'll see whether we wrote all those 6 points. So they said that compare and contrast the bromination of benzene and bromination of phenol. Include equations in your answer. Right. So we told that both reactions are electrophilic substitution. We mentioned that part. Then we wrote the reactions of bromination of benzene. Then we wrote the reaction of bromination of phenol. They said benzene requires a catalyst. So we mentioned that it requires FeBr3, 1, 2, 3, 4. Phenol react with bromine water. Phenol react at room temperature. Allow phenol react with bromine without a catalyst. So what is the point we mention is we say that phenol do not need a catalyst. So we have this point, no problem. Then phenol is more reactive because the lone pair of electron oxygen atom are delocalized into the ring. Yes, that's the point they're asking. We wrote that part. So they say that if you want to add more things, whatever in the brackets is not compulsory to have. Therefore, phenol is making more susceptible to electrophilic attack or making phenol more reactive. But the main point they're expecting is phenol electron cloud, the oxygen atom electron cloud in phenol get delocalized with the electron cloud of the benzene ring. So we have 1, 2, 3, 4, 5 and 6 marks. So this is what is we have in the marking scheme. In a marking scheme, if some answer says is allow. Allow means yes. If you write those points instead of the marking point, yes, you get mark. So allow means is answer. But if they say ignore means, that means even you have written those points, they will not mark you. That means they will not give you mark, but nothing will happen. So ignore means they will not give you a 1 mark for this one. But there will be another part, something called like, let's take for this marking point 5, we have allow answer. If you write allow answer, you get the mark. If you write ignore answer, they don't do anything. They just don't mark it. But if you see another answer called reject, let's take, we have reject. Reject say that they say like phenol need a catalyst. If you said phenol require catalyst, a catalyst is a reject answer. So let's say that you first wrote that in this marking point 4, you saw that phenol reacts with water. That means you got the marking point 5. To marking point 5, they have written reject phenol require catalyst. We say that phenol react with bromine water with the presence of, that's the answer you are going to write, presence of FeBr3 catalyst. Now we have problem. We wrote the answer for marking point 5 and we wrote the reject answer for marking point 5. So since you have written reject answer, what will happen? They will ignore this whole point. You will not get this mark. So remember, if you write allow answer or ignore answer will not give you marks. It will just waste your time. Allow answers are fine, but if you have written something reject answer, you might not get any marks for that marking point, even you have the answer. Because the reason is like sometimes they might ask, do you agree with this statement or not? Something question like that. They will ask, do you agree? Do you agree? Then when you ask, do you agree? Obviously answer will be first yes or no. First you say yes, but I am not agree with that. Are you right? You agree and not agree. So that means both answers are there. No? So then they are in a problem whether to give you the mark or not the mark. That's why they put some answers in the reject. They say, okay, if you have written yes, give you mark. But if you have written the reject part, that means not agree, then this mark and this mark will cancel out each other. So you won't get any mark for that point. That's how they award marks in the marking scheme. So you don't write the reject answer, but if you see allow answers, that's not a problem. That won't be a problem. Okay, if you go for next part of the question, if section say, see, they say that local anesthetics in dentistry. Procaine is a local anesthetic that was commonly used until the end of the last century in dental procedures to numb the area around the tooth. Okay, so this is one of the chemical that they used to use as an anesthetic in dental industry, right? Then dental procedures. Deduce the molecular formula of procaine. Now they're asking the deduce the molecular formula. Molecular formula means simply counting the number of carbon and hydrogen atoms. No? Let's see how we can count it, because they have given us here skeletal formula. So that means they are not showing the carbon atom. So I'll just rewrite those carbon atoms. So this benzene ring has carbon atom here, and there's a carbon atom in this position, and there's a carbon atom here, and there's one here, and there's two here. Okay, I just put the carbon atom. And also they don't show the hydrogen atoms also. Each carbon atom, they need to have 4 bonds. So we know that in benzene, the ring structure is there. No? So each carbon atom should have to have 1 more bond. So this is hydrogen, this is hydrogen, this is hydrogen, this one is hydrogen, and this carbon atom has 4 bonds, no problem. This carbon atom has only 2 bonds, so it has 2 more hydrogen. This carbon atom also has 2 bonds, so 2 more hydrogen. This carbon atom has 2 bonds, so 2 more hydrogen. Same thing for this carbon, 2 more hydrogen. And last 2 carbon atoms should have 3 more hydrogen because it has only 1 bond. Right, now let's see how we are going to count the number of carbon atoms. So when you count the number of carbon atoms, we have 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. So we have 13 carbon. Now let's cancel out the hydrogens. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 hydrogen atoms. You can simply see that there are only 2 nitrogen, one here and the other one here. So 2 nitrogen, oxygen, one here, other one here, 2 oxygen. So the molecular formula for this one is C13H20 N2O2. That's the molecular formula. Right. Let's go for part B. Part B has, okay, it's a sequence of reactions. So its best thing is we should understand this one while we are reading the question. Is understanding them is the best thing. Okay, so what we have here is step 1. So this is simply the theory parts, how the reactions are taking place. You are adding a CH group. So we are there talking about Fiddlecraft alkylation. So for that you have that CH3Cl. That brings the CH group, and the catalyst is anhydrous AlCl3. Anhydrous AlCl3. Then you get CH group will get attached to the benzene ring. Then step 2, you need NO2 group attached to this molecule. To add NO2 group, you have to have the nitration mixture. Nitration mixture means concentrated H2SO4, the catalyst, and concentrated HNO3, and the temperature around 55 degrees Celsius. 55 degrees Celsius. Right. Then step 3, I need to make this CH3 group COOH. To make CH3 group COOH, usually we put oxidizing agent. We usually put KMnO4. KMnO4 is the oxidizing agent that we use to do this reaction. So we put KMnO4. Usually we do it in a basic medium, then we acidify it again to get the COOH group. So basic medium KMnO4, acidic medium KMnO4 will also can perform the reaction. Then step 4, we make this OH group Cl. That means we have to add PCl5. When you add PCl5, OH group get replaced by chlorine atom. So in step 5, okay, for this chlorine atom, so chlorine atom was here. And they have both this huge part of molecule attached to it. We know that chlorine atom, this can form with alcohol. This acid halide can form esters with alcohol. So that means the rest of the group came from outside. Which part? This whole section. Nitrogen. And here. This whole thing is came from the outside. Then that hydrogen is the one who went with the chlorine and combine it here. Then step 6, you make this NO2 group into NH2. So that means tin concentrated HCl. Okay, so we know all the things. So when we read the question, now we have everything in our head. Now let's go for the question. Identify by the name or formula the two reagents needed for step 1. RF. Step 1 we know it, CH3Cl and anhydrous AlCl3. So we just discuss. So we need CH3Cl, chloromethane plus anhydrous AlCl3. Okay, so we got the 2 marks. So CH3Cl 1 mark, AlCl3 is the second mark. So we got 2 marks for that one. Let's go for next one. Then part 2 they're asking for step 2, draw the mechanism of this reaction including the formation of the that means they are asking nitration reaction mechanism. We'll try to remember that nitration reaction mechanism. Okay, we have empty page, so we'll use it. CH3 group, okay. So this is the reaction that we want to perform. So you have CH3. For this one, we are adding concentrated HNO3, concentrated H2SO4, and 55 degrees Celsius. What you are expecting here is CH3 and there will be a NO2 group. Let's remember the mechanism that we have. In this mechanism, what happens? First HNO3. So we have part called formation of the electrophile. Formation of electrophile. Right. So that means what happens is our HNO3 reacts with H2SO4. Concentrated H2SO4 is a very strong acid, so it's forcefully give H plus ion to this HNO3. So when this H2SO4 give H plus ion to this HNO3, what will happen? Our HNO3 will become H2NO3 plus, because H plus ion came there, plus HSO4 minus is produced. This H2NO3 plus is unstable. So therefore it will dissociate into two pieces, H2O and NO2 plus sign. This NO2 plus sign is our electrophile. So what happens here is, now we have our molecule where the methyl benzene. So we have our molecule which is methyl benzene here. CH3. So when the NO2 plus sign comes there, the electron cloud, the pi electron cloud on the methyl benzene uses electron to form a bond with this nitrogen atom. When they form the bond, we will get our intermediate. What happens in the intermediate? Now this NO2 group is attached to this carbon atom, and the hydrogen atom attached to the carbon, that's also there. Then what will happen? Now this benzene ring electron cloud is like broken, because the pi electron cloud is broken because they use electron to form bond with nitrogen atom. Then what will happen? It has a positiveness. So this positive charge goes around the benzene ring. This positiveness. This positiveness only ends when this hydrogen atom leave its electron pair on the benzene ring and go out as H plus ion. Usually when this hydrogen atom goes out as H plus ion, someone helps it to go out, because this HSO4 minus ion is there in the medium. So what HSO4 minus ion will do is, I don't think they will give a mark for that one, but like we can. So this HSO4 minus ion electron pair can be donated to this hydrogen. That's why it goes out as H plus ion. So therefore what we can see here is benzene ring is there. So delocalization is back. Now the electron cloud is there, pi electron cloud, CH3. Now the NO2 group is attached there. The H plus sign goes out. With that HSO4 minus sign, that's again you give you H2SO4. That's why we said H2SO4 is a catalyst. So this is the mechanism which I drew. Now let's see, according to the marking scheme, how many marks I will get. Equation for the formation of electrophile. HNO3 react with H2SO give you NO2 plus HSO4 minus and H2O. Yes. If I add these two reactions, yes, that's the one. I have shown in 2 steps. Yes, they have accept these 2 steps. Curly arrow shows from anywhere in the central ring to the positive ion of NO. Yes. Structure of intermediate is there. Curly arrow from CH bond for the ring. Equation shows the regeneration of the catalyst. Yes. So in my case, I have shown the regeneration of the catalyst in the mechanism itself. Yes, you have all this mark. Those are the marking points that they expect us to write. So we wrote all of them. So therefore we get full mark for this mechanism. Right. If you go for this part 3, for step 5, yeah, we did the mechanism. For step 5, name the type of reaction taking place and draw the skeletal formula of the reagent needed to carry out this reaction. Step 5. Step 5 is this one. Okay. So here acid halide react with an alcohol. So when an acid halide react with alcohol, we know that it's an esterification reaction. We just discussed when you are discussing it. It's an esterification reaction. And if I go back here, how this esterification is formed. So I can see up to here I have this molecule. So that means all this part came from outside. So what is the part which came from outside? Nitrogen atom is here, this part, and this, and this, and this OH. So what happened? How the esterification take place here is this chlorine combined with this hydrogen and they left as HCl, then these two molecules combine. So they are asking esterification and the group which is attached. So those are the two things they are expecting us to write. So we write it as esterification reaction and this whole part group is came from outside. So we just draw it. Right. So that's the formula. Can you see here? They show that now we have do not avoid. They said this one is not avoid for this one. And do not avoid molecular formula, right? Even molecular formula is not enough. So they are asking because they is like specifically they are asking the skeletal formula. So you have to draw the skeletal formula if they are asking for it. So that's the answer for part 3. Then if you go for part 4, identify by name or formula the reagent required for step 6. I think we discussed that one. Step 6 is this one, making NO2 into NH2, tin and concentrated HCl. So those are the two main reagents. Yes, tin and concentrated HCl are the two. So when you are reading the question, we know answer for all these things. So tin and concentrated HCl. Those are the two reagents that we need for this step, last step of the reaction. So that's fine. Right. Okay, next part they are saying, section C, procane contains two nitrogen atoms, one of which is a stronger base than the other. Explain why the basicity of the nitrogen atoms of procane is different. So why they are asking they are different. So if you look at these nitrogen atoms, we discuss basicity of nitrogen. So remember a nitrogen atom become basic because of their lone pair of electron. So what they have to do is they should be able to donate this lone pair of electron. When the H plus sign come, these two nitrogen atoms will donate their electron pair. That's what they do, lone pair, they will donate it. So who can donate this electron pair more effectively or more towards the H plus ion? That's the most basic one. So I can see that there are two nitrogen, one is here, other one is here. So first I am going to write one nitrogen atom is attached to alkyl groups, right? So we can say that one nitrogen atom. So I'm talking about this first nitrogen atom. So you can is attached to two alkyl groups. Okay, that's the first point I wrote. But if you take the other nitrogen atom, is attached to the benzene ring. So other nitrogen atom is attached to a benzene ring. Benzene ring. And then I'm going to tell that the acidity, the basicity depends on how easily they can donate the lone pair of electrons in the nitrogen atom. So next point I'm write that more basic nitrogen atom can donate its lone pair of electrons, of electron easily to a H plus ion. So to an H plus ion. So it can denote it easily to a H plus ion. Right, but we have a problem. When the nitrogen atom is attached to the benzene ring, we know that just like in the phenol case, the lone pair get delocalized with the pi electron cloud of the benzene ring. So therefore, this nitrogen atom will have less electron density. So therefore, its ability to donate electrons towards another H plus ion is very low than the other nitrogen atom. So therefore, I say that next point, the nitrogen atom attached to benzene ring atom electron pair which attached to benzene ring which attached to benzene ring will delocalize delocalized with the pi electron cloud. Therefore, it is less basic. Less basic. Let's take first point. They say that alkyl group attached to nitrogen electron. Okay, there are alkyl groups attached to one nitrogen. Benzene ring attached to the other nitrogen. Right. The basicity of the alkyl nitrogen is greater, or you can say basicity of the nitrogen benzene ring is weaker as the lone pair is less available to accept or attract a proton. Why? Because due to lower electron density, allow basicity of low as it form weaker bonds with proton. So its electron density is less. So we say a nitrogen electron pair which attached to benzene ring will delocalize with the 5 electron cloud, therefore is less basic. We say that more basic nitrogen can donate the electron pair to electron easily. So both these points will cover third point that they ask in the answer. So if you write this answer, you get all 3 points. So we say that we explain about the environment of the two nitrogen atom, and we said that the lone pair of electron in the one which attached to benzene ring will get delocalized with the pi electron cloud. As a result, it will have less electron density. Therefore, it will attract H plus ions less. So that's the point we expect as the answer for this one. Okay, next one they are saying that procane hydrochloride is made by reacting procane with hydrogen chloride 1:1 ratio. Okay, so this is procane. Now you put 1:1 ratio hydrochloric acid. Now we learn that we just discussed. This one is less basic, this nitrogen atom. But this one is more basic. So when I put one hydrochloric acid for one molecule of this one is it contains one H plus ion and one Cl minus ion, because hydrochloric acid aqueous solution means it will separate into H plus and Cl minus ion. So this one has an electron lone pair, so it will form a dative covalent bond with this H plus ion. So what I will see here is this nitrogen has a dative covalent bond. I put arrow to hydrogen atom. So since hydrogen is H plus, overall it will be plus charge and Cl minus ion will be outside. So that's what we expect. Because it's 1:1, only this nitrogen will get protonate, because other nitrogen there's not enough H plus ion to react with other nitrogen. So when the one H plus ion is there, obviously it will be obtained by this nitrogen because that one is more basic. Right, let's go for the marking point. Oh yeah, that's the thing they are talking about. Yes. So here they have put the positive charge on top of the nitrogen atom, but we put it outside the bracket. So what we do is benzene ring, then double bond oxygen, O, nitrogen, oxidative column bond hydrogen, and here we have NH2, and we put positive charge for overall, or they have put positive charge on top of the nitrogen, but we put overall positive charge and Cl minus. So both are accepted. A description that makes a reference to the following points. So we are representing about the positive charge and everything. So we will get full mark for this question. Now we'll go for next one. Explain why procaine hydrochloride is more soluble in aqueous solution such as blood plasma than procaine. So because the reason is when it becomes procaine hydrochloride, it will get a positive charge. That means it becomes ionic. So ionic compounds are more soluble in water. The reason is water is a polar molecule. We know that water has plus delta and minus delta. Minus delta part will attract these plus charges, and the plus delta part of the water molecule will attract these minus charges. Therefore, they are soluble because they form, this is called ion dipole interaction. This is ion. And this is a dipole, permanent dipole. So we call it ion permanent dipole interactions are formed. So therefore, I'm saying that ionic compounds forms ion dipole interaction. So first I'm going to say that procaine hydrochloride is an ionic compound. Therefore, it will form ion dipole interaction with water. Therefore, it will form ion dipole interaction with water. Ion dipole interactions with water molecules. 2 marks, no, that's enough. Okay. Procaine is hydrogen chloride is ionic. Yeah, it's mentioned there. The ions are hydrated by the water and the compound is more soluble and they allow ion dipole interaction. Hydration is same as formation of ion dipole interaction. So you can use hydrated by water molecules or you can write ion dipole interaction. Both points are accepted in this answer. Right. Then we'll go for the last part of the question. They are saying that nowadays procaine has been replaced by lidocaine, a related compound as a local anesthetic in dentistry. Lidocaine is supplied in 2.2 cubic centimeter cartridge that contain 44 milligrams. Okay, they say that 2.2 cubic centimeter contain 44 milligrams. So we have 2.2 cubic centimeters, inside that 44 milligrams. Okay, then they say that from this cartridge a typical dose is 1.5 cubic centimeters. Calculate the number of molecules. All right, typical dosage, even though this is the one, they give only 1.5 cubic centimeter. And they want to know number of molecules here. Right. Now let's see how we're going to do it. So first of all, to find number of molecules, we need to find number of moles. So first we'll find mass before number of moles. We will find how to find mass in 1.5 cubic centimeters. How much mass is there? That's my first question. How many mass is there? Mass is the problem. But we have mass for 44, like 2.2 cubic centimeter. They say that 2.2 cubic centimeter, 44 milligrams. 44 milligrams means 44 times 10 to power minus 3 grams. Where is this 44 times 10 to power minus 3 grams is there? In 2.2 cubic centimeter. If 2.2 cubic centimeter has this much, then how much is there in 1.5 cubic centimeter? How do you find it? First you take 44 into 10 to the power minus 3 in grams. Then you divide by 2.2. Then you multiply it by 1.5. When you do it, you get the answer. 30 times 10 to the power minus 3 means 3 times 0.03 grams. Okay, I know the mass now. 0.03 grams. I found the mass. Now after finding the mass, the second thing is we need number of molecules. So second part, I should know number of moles then. Number of moles in 1.5 cubic centimeters. What to find number of moles? There's an equation for number of moles. Number of moles equals mass divided by molar mass. That means I need the molar mass of this lidocaine because mass I have it. Mass I have it. It's 0.03 grams. Molar mass, as far as remember, it was there in the question. So if I go for the question, it says 234. Yeah, 234 is grams per mole is the. Okay, so we have divided by this number by 234 grams per mole. So if I divide by 234 by 234 grams per mole, so I am going to divide 0.03 divide by 234. I'll get the answer 1.282 into the 10 to the power minus 4 moles. So I get the number of moles. Then they're asking not number of moles, they're asking number of molecules. Now we'll find number of molecules. Number of molecules is a very basic equation. Number of molecules equals number of moles times Avogadro's constant. Avogadro constant, do they have given us, so we have to use 6 into 10 to the power 23. Yeah, data is not given, so we'll use 6.02 into 10 to the power 23. So what you're going to do is number of moles is given, so it's here. Number of moles is 0.03 divided by 234. I'll use this one because I got a lot of decimal places here. That's why, right? And that's the number of moles. Avogadro's constant 6.02 into 10 to the power 23. So when I do this one, when you count something, there's no units, right? So therefore number of molecules will not have any units. If I multiply this one, 6.02 10 to the power 23, my answer will be 7.72 into 10 to the power 19. That's the number of molecules. We'll see our answer whether it's correct. Yeah, we get 7.179 10 to the power 19. So molecule, ignore, calculate number of molecules ideal in 1 cube. So okay, ignore intermediate rounding. So you can't do the intermediate rounding. You have to come till the last point, right? So we have here 7.7179. So they have given answer for like all the points. So whatever that you see in the calculator, so you can write 7.7. So there are many points. So you can write, but 7.72. But this is also fine because we have written for 3 significant figures. So if you write the real answer or this one, or the real answer, what I got here is 7.7179. So we didn't round it up at the beginning. So they say ignore intermediate rounding up. You can't do the rounding up at the beginning. You can do only rounding up at the end. So that's the answer we will get. So from that we will be able to get 3 marks for this one.